Okay, so I thought I would show you something that I've been working on MillenniumOS, and that is both manual and automated probing for one, and I'm going to demonstrate it by using a rectangle block probing cycle. So what I have installed in the machine here is a 6mm dowel in the spindle. That has already had its length probed by the tool setter, which is over here. But that is unimportant for this because we're not going to be probing Z heights. We then have a 1, 2, 3 block with a 3-inch side along here, so this is along the Y-axis, and a 2-inch side along the X-axis, and it's installed in the vise, and it's relatively straight. So what I'm going to do is demonstrate how you would probe the dimensions and the center location of this block using a manual tool. So this command that I have up here is essentially triggering the probe process with values that I know are going to work for this block because I've preset up the block height and I know where the center is. I'm doing this so that we don't have to wait too long jogging the tool around to make it work. When you use this macro from the probe workpiece setup of MillenniumOS, you will be prompted to enter some of these values, and those values are things like the width and the height of the block, and the clearance and the over travel, and the center of the block. You essentially have to jog the tool approximately over the center of the block. So I'm going to send this, and that is going to move the tool to the first location, which is there, and then it's going to ask us for a distance to move towards the target location. Now, my over travel amount is 10. You can see that in the command up there, the T value. So we are approximately 10mm from the surface of the block. Now, that means that we can only move a maximum of 10mm towards that block. There are actually higher values that you can move towards the block, say 20 and 50mm, but we're not allowing that because we know that the distance to the target is less than that. You'll actually see the distance to the target here is 12mm, and that's because we have a 2mm over travel value, which is that O2 value, and that allows us to compensate for sort of inaccuracies in the measuring process. So we're going to measure this using an automated technique, but to have any idea of where to put the probe, we have to have a vague understanding of how big the block is in the first place. So there is a manual thing here. You can measure the block using a set of calipers or a ruler just to get a vague idea of how big it is. So I know vaguely how far away we are, so I'm going to move inwards by 5mm, and then by 1mm, and that's going to be very close to the surface, so I'm going to move in by 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, still not touching, 0.1, 0.1, there, and now we are touching the block. So you can see it still says that our approximate distance to the target is 5.09mm, and all this means is that I was not massively accurate with my with my center point of the block, and also that the tool is wide. So this is a 6mm dowel, so it has a radius of 3mm. So if you remove the tool radius from this, we end up having a distance to the target of 2.09mm, which is pretty accurate given that our over travel is 2mm. So I can now go finish, and that moves on to the next probing location. Now it now occurs to me that the distance is obviously related, when you're probing using a manual tool, the distance to the target is in relation to the radius of the tool itself, so I'll need to compensate for that. So bearing in mind these surfaces are pretty parallel, I should be able to move in by 5, 1, and then 0, 0, 0, 0, 0, 0.1, that is, 0.1, 0.1, 0.1, still not touching, 0.1, that is now touching. And it shows the distance to the target is almost exactly the same as the previous one. So I hit finish, we move on to the next probing location, which is the other surface on X. We do this so that we can calculate the actual center point, so that when we probe on Y, we are a little bit more accurate to the center of the block. So the block is a little bit further out on this side, so I move 2 millimeters in there, 1 millimeter, 0.1. I keep moving it in until it touches. That's touching now. Finish. And then this is the last point for the X surfaces. 5, 1, 1, 0.1, 0.1, 0.1, 0.1. You can see this can get pretty tedious if you have to do it a lot, but there is no other safer way of doing this. This is just if you want to measure a block and know the angles and know all of the dimensions, you need to measure 8 points, and we can only do this safely by allowing you to only move a small distance towards the block at once. So this is a bit harder because from where I'm sitting I can't actually see very easily how far away I am, so I'm going to try and talk around the laptop. I can still see pretty good that we're still quite a long way away. Pretty close now. Keep going. Yeah, and we're against it. So then we move to the next one, and we go in by 5, in by 1. I'm going to go in by 1 again because I think we did that again. Oh yeah, we've got lots of space there. In by 1, in by another one. This is slow going, but it does mean that we will get pretty accurate results, hopefully. Obviously I could be a lot more accurate with measuring. I've just been using the 0.1. It's probably not particularly accurate. I'm probably running a little bit too far into the surface when I'm doing that, but it should be good enough to test with. Pretty close. Oh, I think that's touching, yep. So this should be the last probe point. So we're going to go in by 5, in by 1, in by another one, and in by 0.1, and we're touching. So then I go finish. And that raises the tool back up to the previous height, and it gives us a response in the console. So it shows us that the centre of the block is 154.5 and Y 76.32, and the measured dimensions using a dowel is 50.2. So bearing in mind this is a 123 block, my measured dimensions for this block are 50.21, and my measured dimension for the for this size is 76. I think 219. So it's pretty close. The Y dimension is a little bit off, and that's probably because I was a little bit too aggressive with moving, and I probably deflected the dowel slightly when I was measuring that. So it also says here, setting WCS for XY origin to the center of the rectangle block. So here I specified a command of W4. Now W4 says when you've run the probing cycle, set either the center of the item or the corner to the origin of the work coordinate system that is set. So if I switch back to the dashboard, I've got WCS4 selected, and you can now see the offset in that work coordinate system. So if I go G0, Y0, X0, it should move to the center of the block at the current Z height. So that is the center of our block, and you should be able to see that. Oh, short error, always fun. You should see approximately that it is almost right in the middle of that hole, which you would expect. Cool. So that's that. So if I move this all the way back to the top, I've got Wi-Fi shenanigans. If I move this all the way back to the top, what I'm going to do now is switch the touch probe feature on. So within the macros down here there is a sort of structure for navigating. So under the settings I have toggle touch probe. So now it thinks the touch probe is enabled, or the touch probe feature itself is enabled. So I'm going to go T-1, so this is deselecting the existing tool, which is the datum tool, and then I'm going to go T49, which is the tool number of whatever the measurement tool is. It's either the datum tool or the touch probe, depending on if the feature is enabled. So if I run T49, it's going to ask me to install my touch probe into the spindle. Now, because I've got a dowel in there, I need to uninstall that first. My spindle nut has some metal in it, so it gets a little bit stuck sometimes, and I need to wipe that out. So what I'm doing here is just removing the nut entirely and removing the dowel. I'm then going to install the touch probe into the spindle nut and install that whole thing into the spindle and tighten it up slightly. It doesn't need to be very tight for this because I'm just testing it. That's it. And it also says make sure it's connected, so here is my touch probe cable. I'm going to make sure it's connected here and hit OK. Now I need to manually activate the touch probe to make sure that the touch probe is detected. Now the reason for that is that most AliExpress touch probes are normally open, so they cannot detect cable failures. So if you forget to plug this cable in and then you try and probe the reference surface like this box is asking me to do, the machine would quite happily run the touch probe into the surface and then try and keep going, because it has no ability to detect that the touch probe isn't disconnected. By forcing the operator to actually trigger the touch probe, we can make sure that the touch probe is connected at least when we start the probing move. Obviously if this cable gets disconnected, there's a possibility that it could still fail, but it's better than what we had previously, which is nothing. So now we're probing the reference surface, and the reference surface is this fixture plate down here, and that has a known distance to our tool setter location, and that is the same thing as setting the tool length for our probe, our datum tool. It essentially allows us to measure accurate Z heights for tools. So you can see this is running twice, 3 times, and backing off, and now we have an accurate position of the datum surface, of the reference surface. Now I have another command which is the same command here, but designed to be used with the touch probe. It's exactly the same, except that the length value is different, and the length value is different because the installed length of the touch probe and the datum tool are different. In practice, when you use this macro, if you're not calling this particular macro directly, you will be jogging the tool around to make it work. So you won't actually need to enter heights and that sort of thing. You'll just need to know the width of the you'll just need to know the width and the height of the block, and to be able to jog over the approximate center. Now you can see the touch probe is doing exactly the same moves from exactly the same locations as the datum tool was, but it's doing the move and the back off automatically, and it's also doing repeat probes so that we can average, because these probes they're accurate to, I mean, they're decently accurate, but by doing multiple probes we can reduce the tolerances down, so we have a variance between the probes of less than 0.1 of a millimeter. Obviously we need to wait for this to run, but once it's done it will essentially do exactly the same thing, which is set the positions of the 0 for the work coordinate system, and calculate the angles. And it will also give us a set of dimensions for the block. So you can see there we've done the two X surfaces, and now we move on to the Y surfaces. 1, 2, 3. So you can see how much faster it is, even with doing 3 probes of each location. Having a touch probe is so much faster than doing it manually, and so much less prone to danger, because the machine will stop as soon as the touch probe is activated. These touch probes are, I think, somewhere in the region of about £30 on AliExpress. They are a good investment. You can run this machine perfectly fine using manual tool probes, as you've seen in the past, and MillenniumOS is designed to make that feasible. But you will, if you are running multiple jobs or you're running multiple fixtures within the same job, a touch probe will make these things so much faster. So you can see there the block has finished probing, and the values that we got were 50.81 for the width. Remember we're targeting 50.8, so that's within 0.01 of a millimeter, and we're targeting 76.2 for the length, and we got 76.18, so we're within 0.02 of a millimeter there. You can also see here that we've calculated the rotation of the block. Now, this is the rotation of this side, this side of the block versus the x-axis itself. So you can tell there that the block is only very, very, very slightly misaligned with the x-axis by 0.0005 of a degree, which means essentially the block is perfectly trammed to the movement of the x-axis. Now, there's some other internal values that are generated when running this macro, and those internal values can be used for different stuff. So say, for example, we have a facing macro. We don't have that yet, but it's on the roadmap. Because we've measured the dimensions of the block, we can calculate the bounding box of this top surface. And because we've got a bounding box, we then know if we want to face this block down to a particular level, we know where we need to run the tool. If we've got a tool that's, I don't know, 3 centimeters wide, we can run it down here, then we run it 3 centimeters in down here, and then we run it 3 centimeters in down here, and that would give us a path with 0 step over. So we would obviously want some step over. So say, for example, we were going for 50% step over, we would go here and then move 1.5 centimeters over and run here, and 1.5 and here, and 1.5 here, and 1.5 in here. So we can combine the probe macros with actual cutting macros, for example, to make a facing op or a drilling op or something like that, that combines these things to be able to actually perform machining operations without having to even use a CAM program, in theory. Obviously, for adaptive clearing and other sorts of things like that, doing it in the firmware itself is impossible. We're not trying to replace that, but for certain simple operations where the G-code is easy to generate, it may in theory be possible to do some decent things to reduce to pre-process the workpiece before actually running complex CAM paths. So yeah, I hope that was a bit of an insight into what I've been working on and how the probing system works, and how essentially what I'm trying to do is apply automated techniques to manual probing as well as touch probing. If anyone has any questions, feel free to ask them in YouTube comments or send them to me on Discord. I'd be happy to discuss on Discord if you want to know more about how this works, and I'm hoping that I can have something out for people to use before the LDO kits reach suppliers for the production runs. So yeah, thanks for spending the time with me going through this, and yeah, happy machining hopefully.